Today we're going to talk about the inner planets of our solar system. Now, there are 8 planets in our solar system, and there are other objects that we'll talk about. But the first 4 planets all have something very close in common. They're all very similar. The outer 4 planets all have a lot in common. And then there are those other objects. Now, our solar system contains 8 planets, a couple other dwarf planets, an asteroid belt, comets, all sorts of material. Going at the top, working our way down, you see Mercury, Venus, Earth, Mars, and these are all the terrestrial planets, the inner 4, followed by Jupiter, Saturn, Uranus, and Neptune. Neptune being the farthest planet out of that. And there are 8 planets in our solar system. The inner 4 are called the terrestrial planets. The reason for this, they all have hard, rocky surfaces. They are small. They are very similar size. And this picture here kind of shows their relative sizes. Mercury is the smallest of the 4, followed by Mars. Venus is just a bit smaller than Earth, and then Earth is the largest of the inner 4 planets. Now, really, if you look at these, Venus has a lot in common with Earth as far as size and composition goes. Mars, however, probably the place we travel to first of all the planets. Mercury, well, we would not want to go to Mercury because it's too close to the sun. If you're on the sun-facing side, you'd be pretty much burned to a crisp. So let's start with Mercury. Mercury, when we look at it, actually looks a lot like our moon. It really doesn't have an atmosphere. It's heavily cratered. It's a rocky surface. It even has a very similar color. And here's an image of Mercury. And if I didn't tell you it was Mercury, you'd almost think it was the moon. But this is Mercury. And here's another close-up image. The cratering on Mercury actually looks a little different than it does on the moon because of the size of Mercury. The craters aren't as big. The gravity kind of pulls in the material more easily. There is suggestions that there could have been early tectonic activity on Mercury, but that it cooled off very quickly, and that there might be forces caused by the sun onto it to change its surface. Now, Mercury is closest planet to the sun, orbits about 0.38 AUs. Remember, 1 AU is equal to the distance that the Earth is from the sun. So that's the Earth-Sun distance. So it's about 0.38 times away. The innermost planet is rarely seen because of the sun's glare. It wasn't until we actually had satellites sent out orbiting that we got good pictures of it. Looking at any land-based telescope, you wouldn't really see much when you looked at Mercury. Less than half of Earth's gravity, Mercury remains only a wisp of an atmosphere, presumed to be helium. The lack of significant atmosphere allows temperature to fluctuate from 750 degrees Fahrenheit during the day, that's the side facing the sun, to minus 320 degrees Fahrenheit at night, that's facing away from the sun. So there's no trapping of heat by the atmosphere because there's really hardly any atmosphere to speak of. Rather than atmosphere, Mercury possesses a thin exosphere made of atoms blasted off the surface by the solar wind and striking micrometeoroids. Those are small meteors. Because of the planet's extreme surface temperature, the atoms quickly escape into space. Thin exosphere, there has been no wind erosion on the surface, and meteorites do not burn up due to friction as they do in other planetary atmospheres. Mercury's surface resembles that of Earth's moon, scarred by many impact craters resulting from collisions with meteoroids and comets. While there are areas of smooth terrain, there are also lobe-shaped scarps or cliffs, some hundreds of miles long and soaring up to a mile high, formed by early contraction of the crust. Over the next half-billion years, Mercury shrank in radius about 1 to 2 kilometers as the planet cooled after its formation. The outer crust contracted and grew strong enough to prevent magma from reaching the surface, ending the period of geological activity. So Mercury is pretty much dead now. Venus, the second planet from the sun, is very much Earth's twin. However, you would not survive on the surface of Venus because the atmosphere would crush you. Never mind the sulfuric acid that would be raining down from the sky. Second planet from the sun bakes under twice as much solar radiation as Earth and reaches temperatures of 895 degrees Fahrenheit. And that's hotter than Mercury, even though it's farther away than Mercury. And the reason for this is because of its atmosphere. Pressure from the dense atmosphere of sulfuric acid gas is about 95 times greater than Earth's and would crush a human. After the moon, Venus is the brightest object in the night sky. Of course, the sun being the brightest. So it goes sun, moon, Venus. The dense atmosphere produces a runaway greenhouse effect. At first glance, if Earth had a twin, it would be Venus. The 2 planets are similar size, mass, composition, and distance from the sun, but there are similarities ends. Venus has an ocean. Venus is covered by thick, rapidly spinning clouds that trap surface heat, creating a scorched greenhouse-like world. Temperatures hot enough to melt lead, and pressure so intense that standing on Venus would feel like the pressure felt 900 meters deep in our oceans. These clouds reflect sunlight in addition to trapping heat because Venus reflects so much sunlight, usually brightest planet in the sky. Now, the reason why it's so hot is that it does contain a lot of carbon dioxide, gases in the atmosphere which trap in heat. So whatever light does pass through the atmosphere, hits the ground, gets converted to heat, is trapped, and so it gets very, very, very hot on there. Now, we cannot see the surface by using visible light telescopes. Instead, we had to look at radio waves. We had to use microwaves. We had to use ultraviolet. We had to use everything to try to figure out the composition of Venus. Visible light was being affected too much by the atmosphere. Of course, we know Earth is the third planet from the sun, or third rock from the sun. We have water, oceans. We have a rocky surface. We have oxygen in our air. We have nitrogen in our air. Oh, and we have life, which makes us unique as far as the planets go. The fourth planet out is Mars. Now, Mars is one of the most interesting planets to us because it is the closest one that we'll probably travel to. One is its atmosphere would not crush us. The temperature on Mars does not fluctuate as much as on other planets. It does have a thin atmosphere, and it might be hospitable to life. And also, there's water on Mars. We've sent many probes to Mars. We have little rovers running through it. If you open up Google Earth and you go to the Mars section, you can actually follow the tracks of the various rovers we sent, and they've analyzed it and they found water. Uh, Life may have existed on Mars at one point. We do believe that when it was warmer, maybe there could have been oceans on Mars. But Mars does seem to be the next planet we would travel to. Mars was named after the Roman god of war, most likely because the planet got its name from its red color. Though Mars is smaller than Earth, its surface area is about the same as the land surface area of Earth. Except for Earth, Mars has the most highly varied and interesting terrain of any of the terrestrial planets, some of it quite spectacular. It has the highest volcano in all of the solar system and the lowest valley. Now, scientists believe that 38.5 billion years ago, Mars experienced the largest known floods in the solar system. Water may be pooled into lakes or shallow oceans. But where did the ancient flood water come from? How long did it last? And where did it go? Now, in May 2002, scientists announced the discovery of a key piece in the puzzle. Mars Odyssey spacecraft had detected large quantities of water ice close to the surface, enough to fill Lake Michigan twice over. The ice is mixed into the soil only a meter below the surface of a wide area near the Martian South Pole. Many questions remain. At present, Mars is too cold and its atmosphere is too thin to allow liquid water to exist at the surface for long. More water exists frozen in the polar ice caps. Enough water exists to form ice clouds, but the quantity of water required to carve Mars' great channels and floodplains is not evident on or near the surface today. Images from NASA's Mars Global Surveyor spacecraft suggest that underground reserves of water may break through the surface as springs. The answers may lie deep beneath Mars' red soil. And up to this point, we've really only been able to dig very deep, very shallowly with the rovers we've had. So it's going to take a actual group of scientists traveling to Mars and digging deep to see if there's water down there. But the landscape reminds us so much of various parts of Earth where we see the effects of erosion. We see those same features found on Mars. So it's safe to assume water is there. Now, Mars has two small moons, and so of the four terrestrial planets, these are only the other two moons that we see. They're called Phobos and Deimos. Although no one knows how they formed, more than likely they are asteroids that were pulled in by Mars's gravity. Mars is just inside of the asteroid belt, and so it's very logical that two asteroids, small ones, could be pulled in by Mars's gravity. Their shape, their composition does not allow them really to be probably formed the same way that our moon formed. The only other possible moon you could say in the inner four planets is that recent studies have shown that there's a object that has the same orbit around the sun as Venus, and so it could have a pseudo moon. But really, Earth has one large moon, Mars has two small moons, and these guys may actually be pulled in eventually by Mars's gravity and into the surface.